Aviation for me has been like a lifetime journey, lifetime experience. I go all the way back to my mother when I was 8 years old, and that captured my heart. I mean, that was what I wanted to do, what I wanted to be. In the 1980s, I was deeply involved with, a military flying experience, training in particular to become the very, very, kind of Top Gun pilot. And the initiative that kind of propels me today with electric aviation is the ability to bridge from the past to the future. FAA certification is the gateway of quality, the gateway of safety. For the first time ever, we now have a process with them for electric propulsion on airplanes. We start the innovation around a two-seat airplane, the E-Flyer 2. Advanced composites, advanced aerodynamics, high technology, very latest in avionics. Electric motors and batteries and the trajectory of their evolution from 10 and 20 years ago to present day makes possible for the first time a very, very disruptive, lower operating cost, no CO2, and very low noise. That's the piece that changes everything.
We are an all-composite airplane, very low parts count, but yet it's a robust system.
One of the best-selling points of this aircraft is the range of the aircraft, which weight directly affects that. So we are using FiberSim, which is a Siemens product, to optimize the structural integrity of the composite airframe.
NX provides the outer shape of the plane, and then FiberSim builds the layers of composites up from the outside in.
Every plane starts with a conceptual design where you have an idea of what your plane should look like, what its performance characteristics need to be, and based on that you start designing the systems inside the aircraft.
We're designing the E-Flyer 2 with change in mind. We're using a top-down design process enabled by Wave, which is a capability in NX. Enables us to simply update the models to the changes around them.
What helps Aerospace be agile in our design process is the wave linking, is the ability to create a top-down structure where you can take something as simple as a shape and break it down into pieces and pass it down to the people that are responsible for designing those pieces.
The CAD file is the center of everything we do. We consume the CAD file. It directly feeds into that file. The integration between NX and the model, the drawing, the sim is very, very robust and strong.
We have high voltage systems, batteries that we are trying to route to each other to connect all the high voltage components of the assembly together, and that's where the harness and routing tools come into play. And Capital comes into play in a big form. You can actually have your harness layouts in Capital and link them in 3D into NX, where you can actually visualize them inside the aircraft.
We can take the E-Flyer 2 in the end. We'll change that aerodynamic shape to what it needs to be for an E-Flyer 4, and then we'll morph the E-Flyer 2 into an E-Flyer 4. I anticipate that'll take about a week to do. It's an order of magnitude savings. You can either do the same number of iterations in less time, or you can do more iterations in the same amount of time. At Aerospace, we're doing both. We're shrinking our product development time and doing more iterations at the same time. In the end, what that allows us to do is to get to market fast with the right plane.
We have 20 people on the engineering team. A typical company would have 50 to 60. And the reason we can do that is because the Siemens suite is so integrated that you don't need the traditional specialists.
As a systems engineer, I feel that the biggest advantage of the Siemens software is how it makes design more collaborative.
The NX CAD software in particular that we're using right now is a technology enabler. It keeps Aerospace in front. The ability to capture all of the aspects of an airplane design is greatly enabled. In the capturing of the E-Flyer 2, the transition to what comes next is particularly a capability that the Siemens software can do for us.